Hello, my name is Kevin Day. This is my capstone proposal project on detecting Trojan malware in Android banking applications. This project was presented to the Department of Science and Cybersecurity in partial fulfillment of the requirements for the degree of Masters of Science in Cyber Operations. Mobile devices have become the most prevalent method of accessing services via the Internet. Mobile banking applications have become the primary channel for customers accessing banking and account services. Mobile banking apps collect and store large volumes of personal identification information in a single location, resulting in developers creating malware which targets mobile banking applications, with the number and types of malware targeting these type of applications will only increase in the near future. Detection remains a challenge due to the constant evolution of methods used to evade existing detection and security solutions. Some background information on the Android operating system. It's a mobile operating system created from a modified version of the Linux kernel and other open source software. It's free, open source, and the source code is part of the Android open source project. The current version is Android 11.0. Mobile banking Trojans on the Android platform are one of the most rapidly developing and flexible and dangerous types of malware. A Trojan consists of two parts: the server side, which is the attacker host, and the client side, which is the attacker's console. Normal Trojan capabilities are such as backdoors, sniffing, spamming, and keylogging. Present mobile banking Trojans. The two most recent are Cerberus, where in August 2019 the source code was made public, and since then development has become abandoned. The newest type is Alien. In January 2012 it was released in the wild. It's a new variant of Cerberus. The new method this type is employing is new ways of invading Protect Play, which is Google's built-in malware detection service. It enables itself in fake application files and version updates for applications. The research questions for this project are: how is it spread? When was it discovered? Estimated time it's been in the wild, the rate of infections per device, estimated time to infect a device once installed. Also, what is the classification and taxonomy, the payload, what are the effects on device hardware and software, and can the malware be successfully removed? And if so, what is the level of difficulty to remove it? The anticipated impact of this research will be development of robust and accurate detection of Android Trojan malware applications for banking and mobile industry. Mitigation of Trojan malware on the application platform can result in more secure environment protections, personal identification information, and many other applications. The methodology will first start with academic research, reading academic papers, reviewing the Android source code, reviewing other Android Trojan malware source codes, interviewing with other cybersecurity professionals, mainly in the banking industry. Next will be a data acquisition, followed by lab experiments. The main focus will be identifying detection Trojan malware, classification of their features, and isolate the malware itself. The two branches this can fall into will be application development, which will start with UML modeling for the interface. The toolkits used will be the Android Development Kit for the standard development using Java, and also the native development kit using C++ to enable more lower functions. The development environment will be Android Studios and Linux, and also a Linux IAD as well. And then the end goal would be to deploy this application in the Google Play Store. The thesis part would be doing quantitative analysis of impact of Trojan malware in Android banking applications, doing qualitative analysis of the behavior of Trojan malware within the Android OS, quantitative analysis of the rate of Trojan malware infections on Android devices, qualitative analysis of Trojan malware infecting infection vectors on Android devices. The cyber operation courses throughout my program will Cyber 621 Secure Systems Program and OS Theory, currently in fall 2020. In spring, Cyber 681 Malware Analysis and Reverse Engineering. And then the 2 summer courses, Cyber 611 Vulnerability Discovery and Exploration, and Cyber 665 Securing Wireless and Mobile Technologies. Tentative project timeline: proposal November 2020. Proposal itself will be December 2020. Research will be completed April 2021. App planning and coding will stop in December 2021, and testing and debugging complete will be June 2022. The main references used for this project will be banking Trojan APK detection using formal methods, a cyber kill chain taxonomy of banking Trojans for evolutionary computer intelligence, the rise of Android banking Trojans, Android security survey of issues, malware penetration and defense, mobile banking, evolution and threats, malware threats and securities. Thank you, and I hope you enjoyed the presentation.